In this video, we're going to learn how parallel arrangements of planar and linear grains can form planar and linear fabrics, and learn how to distinguish between them. In the first model we have today, we can see a cube with a randomly placed but parallel arrangement of those hexagonal mica grains throughout the cube. If we look just at the edges of the cube, we can see that on four sides of the cube, we're looking at the edges of the grains of mica, which will therefore define relatively linear shapes. Whereas on the top and the bottom of the cube, we can see the hexagonal equant shapes of the mica surfaces. Now let's have a look at linear fabrics. Our model shows us, again, randomly placed but parallel arrangements of the amphibole grains within the cube. Let's have a look at what they look like on the outside of the cube. Once again, we can see that on four surfaces of the cube, we're looking at the edges of the parallel amphibole grains, and therefore we'll see basically a collection of parallel lines. Whereas on the other two faces, we'll be looking at the equant diamond-shaped cross-sections of those amphibole grains. So let's now compare those two models side by side. Here they are. As we look around the two models, we notice the similarity that in both cases there are four sides of the cube in which we see parallel lines denoting the edges of respectively the mica and the amphibole grains. On the other two sides, in the one model, we'll see the hexagonal shapes of the mica grains, which have got dimensions comparable to the edges that we see on the other sides of the cube. Whereas for the linear fabric, we can see the cross-sections of the amphibole grains, which are much smaller than the dimensions of their length. But the really critical difference between the two models is that the sides of the cube which show the equant grain shapes, up here for the micas, here for the amphiboles, have got a different relationship to the sides that show the linear cross-sections. In the mica case, that surface, this top one here, which shows the equant shapes of the hexagonal shapes of the micas, is parallel to the surfaces which show the elongate lengths of those mica grains. Whereas, in the case of the amphiboles, the surface here with the cross-sections, the diamond-shaped cross-sections, is perpendicular to the surfaces which show their length. And that is the key difference between these two fabrics. Notice that this method of distinguishing planar and linear fabrics will work whatever the orientation of the fabrics, as long as we can see them on planes in several different orientations.